Hello everyone! Today we're going to discuss differentiation of algebraic function in differential calculus. Before we solve an algebraic function, we need to discuss first the different differentiation rules that we're going to use. First is the derivative of a constant. Take note that the derivative of a constant is equivalent to 0. We have the formula, the derivative of c with respect to x is equivalent to 0. Next is the derivative of a sum. The derivative of the sum of two functions is equal to the sum of their derivatives. Take note that u and v here are differentiate function of x. We have the formula, the derivative of u plus v with respect to x is equivalent to the derivative of u with respect to x plus the derivative of v with respect to x. Next is the derivative of a product. The derivative of the product of two functions is equal to the first function times the derivative of the second plus the second times the derivative of the first. Take note that u and v are differentiate function of x. We have the formula, the derivative of uv with respect to x is equivalent to u times the derivative of v with respect to x plus v times the derivative of u with respect to x. Next is the derivative of a quotient. The derivative of the quotient of two functions is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. Take note that u and v are differential function of x. We have the formula, the derivative of u over v with respect to x is equivalent to v multiplied by the derivative of u with respect to x minus u multiplied by the derivative of v with respect to x divided by v squared. Next is the derivative of the product of a constant and a function. The derivative of a constant times a function is the constant times the derivative of the function. We have the formula, derivative of cv with respect to x is equivalent to c multiplied by the derivative of v with respect to x. Next is the derivative of the reciprocal of a function. Given that the numerator is a constant and the denominator is any function, the derivative will be the negative constant multiplied by the derivative of the denominator divided by the square of the denominator. We have the formula, the derivative of 1 over v with respect to x is equivalent to negative derivative of v with respect to x divided by v squared. Next is the derivative of x to the power of n, or what we call as the power rule. The power rule tells us how to differentiate expressions of the form x raised to the power of n. We have the formula, the derivative of x raised to the power of n with respect to x is equivalent to n times x raised to the power of n minus 1. If you find this video helpful, please consider clicking the like and the subscribe button to show your support so that I can make other videos like this. To apply the formulas we have discussed a while ago, let's have some examples. Let's differentiate the following functions. Number 1, we have y is equals to 2x cubed minus 7x plus 1. Here, we need to use the derivative of the nth power, which is the derivative of x raised to the power of n with respect to x is equivalent to n times x raised to n minus 1. And also, we're going to use the derivative of a constant, which is the derivative of c with respect to x is equivalent to 0. Thus, we have the derivative of y with respect to x is equivalent to, for 2x cubed, we're going to use the formula of the derivative of the nth power. So we have 2 multiplied by, our n here is 3. So that's why we have 3 multiplied by x raised to the power of 3 minus 1. Minus, for 7x, we're going to still apply the derivative of the nth power. So we have 7 multiplied by x raised to the power of 1 minus 1. Plus, 1 is a constant, so that is the time we're going to use the derivative of a constant, which is equivalent to 0. Simplifying it, we have 2 multiplied by 3x squared minus 7 multiplied by x raised to the power of 0 plus 0. So we have the derivative of y with respect to x is equivalent to 2 times 3x squared. So we have 6x squared minus 7 times x raised to the power of 0 is equivalent to 7. Because we all know that x raised to the power of 0 is equivalent to 1. So we have our final answer, which is 6x squared minus 7. For number 2, we have y is equals to 1 over v squared minus 2 over v raised to the power of 4. To solve this, we have to rewrite the given function. So we can transform this one into an exponential form. So to transform 1 over v squared into an exponent form, so we have v raised to the power of negative 2 minus 2 over v raised to the power of 4 will become 2 times v raised to the power of negative 4. Next is we're going to use the formula for the derivative of the nth power, which is the derivative of x raised to the power of n with respect to x is equals to n multiplied by x raised to the power of n minus 1. Thus, we have the derivative of y with respect to v is equivalent to, for v raised to negative 2, we're going to apply derivative of the nth power. Here, our n is equivalent to negative 2. That's why we have negative 2 multiplied by v raised to negative 2 minus 1. Minus, for our 2 times v raised to negative 4. So, we're going to write first our constant, which is 2. Then for v raised to negative 4, our n here is negative 4. So that's why we have negative 4 times v raised to the power of negative 4 minus 1. Simplifying it, we have the derivative of y with respect to v is equivalent to negative 2 times v raised to negative 2 minus 1. So we have negative 2 times v raised to negative 3 plus simplifying negative 2 multiplied by negative 4. We have positive 8. Then v raised to negative 4 minus 1. So we have negative 5. So our final answer is equivalent to the derivative of y with respect to v is equals to negative 2 multiplied by v raised to negative 3 plus 8 times v raised to negative 5. Then transforming it into a fractional form, we have the derivative of y with respect to v is equivalent to negative 2 over v cubed plus 8 over v raised to the power of 5. For number 3, we have x is equals to the square root of t minus 1 over square root of t. To solve this easily, we're going to transform or rewrite the given function into an exponent form. So we have, for square root of t, we can rewrite that as t raised to the power of 1/2. And for 1 over square root of t, we can rewrite that as t raised to the power of negative 1/2. So we have the other form for our x, which is x is equals to t raised to the power of 1/2 minus t raised to the power of negative 1/2. Here we're going to use the derivative of the nth power, which is the derivative of x raised to the power of n with respect to x is equals to n multiplied by x raised to the power of n minus 1. Thus, we have the derivative of x with respect to t is equals to, for t raised to 1/2, applying the derivative of the nth power. So we have n, which is equivalent to 1/2. That's why we have 1/2 multiplied by t raised to 1/2 minus 1. Minus, for t raised to negative 1/2, so still applying the derivative of the nth power, our n here is negative 1/2. So that's why we have negative 1/2 times t raised to the power of negative 1/2 minus 1. Simplifying this, we have the derivative of x with respect to t is equals to, for 1/2 times t raised to 1/2 minus 1, we have 1/2 times t raised to negative 1/2. For negative 1/2 times t raised to negative 1/2 minus 1, we have negative times negative, we have positive, then copy 1/2, Then for t raised to negative 1/2 minus 1, we have t raised to the power of negative 3 over 2. Therefore, the derivative of x with respect to t is equals to 1/2 times t raised to negative 1/2 plus 1/2 times t raised to negative 3 over 2. Then, we're going to transform that one into fractional form. So, we have the derivative of x with respect to t is equals to 1 over 2 square root of t plus 1 over 2 square root of t cubed. Then as you can see, there is a common which is 1/2, so we can put it outside. That's why our final answer, the derivative of x with respect to t is equals to 1/2 quantity 1 over square root of t plus 1 over square root of t cubed. For number 4, we have y is equals to v squared plus 3 multiplied by v squared minus v plus 1. To solve this, we're going to use the derivative of the product, which is the derivative of uv with respect to x is equals to u multiplied by the derivative of v with respect to x plus v times the derivative of u with respect to x. To solve this, we're going to let our u, which is equivalent to v squared plus 3, and our v, which is equivalent to v squared minus v plus 1. So, for our u multiplied by the derivative of v with respect to x, we have u, which is v squared plus 3. For the derivative of v with respect to x, we have v squared, applying the derivative of the nth power. The n here is 2, that's why we have 2 times v raised to 2 minus 1. For negative v, applying the derivative of the nth power, this will become v raised to 1 minus 1. That gives us v raised to 0. So that is equivalent to 1. That's why we have negative 1 here. Then for positive 1, so since positive 1 is a constant, so derivative of a constant is 0. That's why we have plus 0 here. Next is we're going to evaluate the v multiplied by the derivative of u with respect to x. Our v here is equivalent to v squared minus v plus 1. Then for the du over dx, so we have for v squared, applying the derivative of the nth power, our n is 2. That's why we have 2 times v raised to the power of 2 minus 1. Plus 3 is a constant, so derivative of a constant is 0, so that's why we have plus 0 here. So we have now our derivative of y with respect to v is equals to, we will just bring down v squared plus 3. Then we're going to simplify our 2 times v raised to the power of 2 minus 1. That gives us 2v. Then bring down minus 1 plus bring down v squared minus v plus 1. Then we're going to simplify 2 multiplied by v raised to the power of 2 minus 1. That gives us 2v. We're going to apply FOIL method for v squared plus 3 multiplied by 2v minus 1. So we have v squared multiplied by 2v. We have 2v cubed. Then v squared multiplied by negative 1. We have negative v squared. Next is 3 multiplied by 2v. We have positive 6v. Then positive 3 multiplied by negative 1. So we have negative 3. That's why we have here 2v cubed minus v squared plus 6v minus 3. Next is we're going to multiply 2v to v squared minus v plus 1. So we have v squared multiplied by 2v. The answer is 2v cubed. Then negative v multiplied by 2v. So we have negative 2v squared. Then positive 1 multiplied by 2v. So we have plus 2v. Combining all the commons, so we have 2v cubed plus 2v cubed, that gives us 4v cubed. Then negative v squared plus negative 2v squared, that gives us negative 3v squared. Then positive 6v plus 2v, that gives us 8v. Then bring down negative 3. So our final answer for the derivative of y with respect to v is equals to 4v cubed minus 3v squared plus 8v minus 3. For number 5, we have y is equals to 1 over 3x minus 2. In solving this one, we're going to use the derivative of the reciprocal, which is the derivative of 1 over v with respect to x is equals to negative derivative of v with respect to x over v squared. Our v here is equals to 3x minus 2. So our derivative of y with respect to x is equals to negative 1. Then deriving our v with respect to x, which is 3x minus 2. For 3x, we're going to apply the derivative of the nth power. So we have 3 multiplied by x raised to the power of 1 minus 1. For negative 2, since it is a constant, derivative of a constant is 0, so that's why we did not write anything here because it is equivalent to 0. Next is our v squared. Since our v is equivalent to 3x minus 2, so we have 3x minus 2 squared. Simplifying this, we have the derivative of y with respect to x is equals to negative for 3x raised to the power of 1 minus 1. So we have 3x raised to the power of 0. Then copy 3x minus 2 squared. Then we all know that x raised to the power of 0 is 1. So we have the derivative of y with respect to x is equals to negative 3 divided by 3x minus 2 squared, which is our final answer. For number 6, we have y is equals to x squared over x plus 1. To solve this, we're going to use the derivative of the quotient, which is the derivative of u over v with respect to x is equals to v multiplied by the derivative of u with respect to x minus u multiplied by the derivative of v with respect to x, all divided by v squared. Our v here is x plus 1 and our u here is x squared. Let's evaluate first the v du over dx. So our v here is x plus 1. Then the derivative of u with respect to x is, for our x squared, we're going to apply the derivative of the nth power. So here our n is 2. So that is why we have 2 times x raised to the power of 2 minus 1. For our u dv over dx, our u here is x squared. Then the derivative of our v, for x, we're going to apply the derivative of the nth power. So we have x raised to the power of 1 minus 1. And for 1, so since this is a constant, so derivative of a constant is 0. So that's why we have a 0 here. Then all will be divided by the square of our v. Since our v here is x plus 1, so that's why we have here x plus 1 squared. So now we have our derivative of y with respect to x is equals to, we will just copy x plus 1. Then simplifying 2 times x raised to the power of 2 minus 1. So we have 2x, then minus, then we're going to copy x squared. Then simplifying x raised to the power of 1 minus 1. So we have x raised to the power of 0. Then we know that x to the power of 0 is equals to 1. So that's why we have times 1 here. Then all will be divided by x plus 1 squared. Multiplying x plus 1 times 2x, we have x times 2x gives us 2x squared plus 1 times 2x gives us 2x minus x squared times 1 gives us x squared. Then we're going to divide it with v squared, which is x plus 1 squared. That is why our derivative of y with respect to x is equals to 2x squared plus 2x minus x squared divided by x plus 1 squared. Combining the common, which is x squared, so we have 2x squared minus x squared gives us x squared. Then we will just copy 2x divided by x plus 1 squared. That's why we have our derivative of y with respect to x, which is equal to x squared plus 2x over x plus 1 squared. As you can see, there is a common in the numerator, which is x, so we can factor it out. That's why our final answer for the derivative of y with respect to x is equals to x quantity x plus 2 over x plus 1 squared. That's all for today's video. I hope you learned something from this. Thank you for watching. Goodbye.